This video describes a new method for construction of large-scale offshore wind power. The engineering is led by the University of Delaware, funded by the U.S. Department of Energy. We use existing equipment, but new methods, seeking to industrialize fabrication, reduce costs, and make production scalable. The process begins in an assembly port set up for this purpose. In conventional offshore wind turbine construction, components are staged in a port, loaded separately onto a transport vessel, and assembled in the ocean at the site of each turbine. Our new construction method also begins with staged components, but they will be fully assembled before leaving the port. Each turbine structure will be anchored to the seafloor with 3 suction buckets, also called suction piles or caissons. We have redesigned the entire assembly and transport process based on suction buckets' unique characteristics. The first step positions the buckets as the base area. The 600-ton subsea jacket structure is then lifted, aligned with the buckets, and welded into place. The 2 tower segments are lifted and attached. Then a novel blade holding bracket is attached to the tower. Each blade is brought to assembly, lifted, and lowered into its blade holding bracket. Attaching blades to the stationary tower reduces wind force on the structure in the yard and during transport to the ocean site, and prevents damage to the drivetrain during movement. The nacelle is lifted, aligned, and bolted on top. In-port turbine assembly is now complete. Despite the size and weight of the entire assembled structure, it can be moved by self-propelled modular transporters, or SPMTs. SPMTs carry completed turbines to a storage area. Turbines can stop en route at a station for in-port commissioning of electric power, controls, and monitoring systems, further reducing time and cost at sea. Queuing of assembled commissioned turbines in port means that the continuous assembly process can efficiently supply weather-dependent, intermittent offshore construction. As installation of each turbine is scheduled, SPMTs pick them up from the staging area and transport to quayside for vessel pickup. Transport is done with an existing vessel like the Gulliver, designed for marine salvage, with a shear leg crane capable of lifting 4,000 metric tons. The vessel picks the complete turbine structure using the specially designed lifting ring built into the tower base above the center of gravity. It lifts directly off the SPMTs. The structure is lowered partway into the water and securely attached to the vessel. The crane vessel delivers the turbine to the ocean installation location. Small vessels have prepared each turbine site, including a subfloor scan 12 meters down, using Pangeo subsea acoustic core or similar equipment. If needed, preparation may include seafloor leveling of contact areas. The crane vessel does not jack up. It positions precisely, then lowers the turbine structure to the floor. On contact, the mass of the structure presses the buckets into the seafloor about 3 meters, depending on soils. Small vessels monitor and control operation of the high-powered pumps, removing water from each bucket, thus slowly drawing the buckets into the seafloor and leveling the tower. Once the structure is secure, the crane vessel returns to pick up the next turbine structure. After use, the pumps are lifted to the service boat and returned to port for the next installations. With the turbine anchored to the seafloor, a small crew can enter the nacelle and safely install the blades, if necessary, waiting for low wind conditions. Each blade is installed using 2 winches in the nacelle and a constant tension winch below, holding the blade bottom for stability. The hub rotates and the nacelle yaws to receive each blade. After attaching the blades, the blade mounting brackets are lowered and returned to port. This innovative blade installation method requires more elapsed time for a small crew, but eliminates the need for jack-up crane vessels to lift and install blades. When the blades are installed, the turbine installation is complete. After adding power cable connections, scour protection, and brief final testing at sea, it can start producing electricity. There are many advantages to this new method compared with today's standard practice. The University of Delaware Wind Power Program led the efforts by these contractors and collaborators, funded by the U.S. Department of Energy.